Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one trig question lost more marks than almost anything else on last year's papers. And the truth is, it's easy if you pick the right rule and label the triangle properly. If you guessed the wrong angle to pair with a side, you could lose a whole method mark without realizing. Stay with me. This will save you time under exam pressure.
Right. First principle. When do you use the sine rule and when do you use the cosine rule? Keep it simple. Use the sine rule when you know either two angles and one side, or two sides and a non-included angle. Use the cosine rule when you know two sides and the included angle, or when you know all three sides and want an angle. Say that again. Included angle, cosine. Non-included angle, often sine. Let's work through this step by step.
Naming. Always label your triangle. Call the vertices A, B and C, and write opposite each vertex the lowercase side A, B and C. If angle A is opposite side A, angle B opposite B, angle C opposite C, you will avoid the classic error of mixing up which angle pairs with which side. Write it down before you start calculating.
The formulas, spoken plainly. The sine rule is sin A over A equals sin B over B equals sin C over C. The cosine rule for a side is c squared equals a squared plus b squared minus 2ab cosine C. For an angle, cosine C equals a squared plus b squared minus c squared all over 2ab. Say the words as you write the symbols. That helps memory and reduces sloppiness.
Worked example. Triangle ABC with A equals 9 centimeters, B equals 12 centimeters, and angle C equals 55 degrees. The question, find side C, then find angle A. Look at our information. Two sides and the included angle C. That matches the cosine rule, so we use cosine to find C. Write the cosine rule down exactly. C squared equals a squared plus b squared minus 2ab cos C. This line is worth a method mark. Write it even if you feel unsure.
Substitute numbers carefully. C squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times cos 55 degrees. That is, C squared equals 81 plus 144 minus 216 times cos 55 degrees. Do that multiplication in your calculator, but show the substitution on the paper. The examiner wants to see your method. Evaluating cosine 55 degrees is about 0.5736, so 216 times cos 55 is roughly 124. Subtract from 225 gives about 101. So c squared is approximately 101, and c is the square root, about 10.05 centimeters. Box the final value with units. That's your A mark. The examiner sees the cosine setup, M1, the arithmetic, M1, and the final value, A1. Let that sink in.
Next, find angle A. Now we have side A equals 9, side C approximately 10.05, and angle C 55. This is a non-included angle situation for angle A, so the sine rule is perfect. Sine A over A equals sine C over C. Write sine A equals A times sine C over C. Substitute the numbers and calculate A using inverse sine. Again, write every step.
Compute numerically, sin 55 is about 0.81915. Multiply by 9 gives 7.372. Divide by 10.05 gives about 0.7336. Take inverse sine and angle A is about 47.2 degrees.
Then you can find angle B quickly as 180 minus A minus C, about 77.8 degrees. Write those three angles with degrees and you're done.
Exam technique, what the examiner actually rewards. For the cosine step, this is typically M1 for writing c squared equals a squared plus b squared minus 2ab cos c, another M1 for evaluating the right-hand side correctly or rearranging correctly, and A1 for the final value with appropriate units. For the sine step, M1 for writing sine A over A equals sine C over C, M1 for correct substitution, and A1 for the correct angle to suitable accuracy. That's two clear 3-mark chunks in this question. Marks are there for the taking. Don't skip the check.
Common mistakes to avoid. Labelling errors. Using the sine rule when the known angle is the included angle. That gives the wrong setup. And calculator errors with degree versus radian mode. Quick exam habit. Before you press equals, a quick glance at your calculator screen to ensure DEG is showing saves a lot of lost marks.
The quick win. A 10-second angle length check that catches most errors. After you compute, do two things. 1. Check the triangle angle sum. A plus B plus C should be 180 degrees to within rounding. 2. If you used the sine rule, check the ratio sine A over A equals sine C over C numerically. They should match to the same number of significant figures you used. This takes 10 seconds and catches sign mix-ups, wrong labelling and mode errors. Trust the process. It pays off.
Guided practice. 2 quick variations you can try now under timed conditions. First variation. Given angles A equals 40 degrees and B equals 65 degrees and side A equals 7 centimetres, find side B. Since you know 2 angles and 1 side, use the sine rule. B equals A times sin B over sin A. Substitute, calculate, and box your answer with units. That's a short 2-mark or 3-mark question normally.
Second variation. Given 3 sides, 6, 9, and 11, find the largest angle. Use the cosine rule. Cos opposite equals the sum of the squares of the other two minus the square of the opposite, divided by twice the product of the other two. For the side 11, cos C is negative small number, giving an obtuse angle around 92 degrees. When you see an obtuse result, it's a useful sanity check against your sketch. If the largest side gives the largest angle, your working is consistent. Write your formula, substitute, evaluate, and label the angle.
If you get stuck in the exam, write down the formula you would use and substitute the numbers you know. Even if you can't finish the arithmetic, that first line often earns a method mark. Write it down, don't just think it. Marks are there for the taking.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable practice questions at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.